Okay, so I want to go over exercise 15H, exercise number 8, because that just constantly shows up on every single IB exam. So the question is, you can read it. You can read it right here. Take a picture or go to the page. Good. So we have the 6 roots of unity. So we have the solutions of the equation of z to the 6 equals 1. And we know from the exercises that the first root is 1, right? And then the second root, which they denote wi, right? And then the third root is that they're going to call W2. The fourth root, they're going to call W3, and then so on and so forth. The fifth root, they're going to call W4, and the sixth root, they're going to call W5. Okay, now, what's the point? And then they say, show that Wn is equal to W1 to the nth power. So for example, the second root is actually this W1 squared, or that W5 is actually this second root to the 5th power. And so the question, well, what's going on there? How is that possible? Well, let's go back to the cheating method I taught you. I said that we take 360 and divide it by 6, and we get 60. Okay? Now, we know that we have roots of unity. The first root is 0, or cis 0. And then I said, oh, just keep adding 60s. But, so you like, okay, the first root is cis 60, right? But what does it mean to add on 60s? Well, if I'm telling you to rotate something 60 degrees, and by when you rotate, we know that these are vertices of a hexagon that are equidistant around the center. So I'm saying add on 60, but in a previous lesson I said when you're rotating by 60, it's like multiplying by cis 60. So this technically is, my first root, W1, and then I'm multiplying by cis 60 to get to 120. And then technically to get to W3, you're doing it again. And so on and so forth. That's where these powers come from. Because just to reiterate, rotating by 60 degrees is like multiplying by cis 60. Hence, W1 is my original first rotation. And then here, this is W1 squared. This is W1 cubed. This would be W1, and then the fourth rotations. It would be like first rotation, second, third, fourth, and then W5, which is the 6th root, is like the first rotation, the second rotation, the third rotation, the 4th rotation, the 5th rotation. Nice. Last thing. Now, then the next thing they want to know is, they say, hence, show that the sum of the roots is equal to 0. 1 plus W plus 1 plus W2 plus W3 plus W4 plus W5 equals 0. Show it's 0. Well, I'm going to take a look at this. Because you're looking at that, and maybe you're tired and you go, oh, that's a geometric series. Well, it's not, because we don't have exponents. But you know what? They just show how to turn it into a geometric series. It's the same thing with every single one of these problems. Whether they show up or not, but it's in the book, it's on the old IB problem. So, you know what? Let's just call W1 W. W2 is actually W squared. The fourth root is actually that second root to the 3rd power. this fifth root is actually the second root to the fourth power, and the sixth root is actually the second root to the fifth power. Well, now we definitely have a geometric series. So how do I add a geometric series? Well, we know there's 6 terms. The first term is 1. And the common ratio is that W, or whatever that Greek symbol is. So the sum of the 6 terms is equal to 1 times 1 minus W to the 6 over 1 minus W. What do we do with that? Well, we're going to need a little trick I told you. Because I said, for the quick way to do this is just keep adding 60s. Well, you have 0, 60, 120, 180, 240, 300. If I had another 6, if I actually, W6, well, this was cis 300. Well, where did the 6th root take me? Is there another root? You say, no, Mr. Adler. That's actually back to the beginning. That means W to the 6 equals 1. That means we have 1 minus 1 equals 0. Hence, the sum of the roots of the unity are equal to 0.